Welcome to today's episode of photosynthesis, the light-independent reactions, otherwise known as the Calvin-Benson cycle. Here we have RUBP, a 5-carbon compound, and a lone carbon, who's actually part of carbon dioxide. The first step in the Calvin-Benson cycle is the fixation of the C in carbon dioxide. This carbon will join with RUBP, forming an unstable 6-carbon compound. Since this 6-carbon compound is unstable, it immediately breaks down into 2 3-carbon compounds called PGA, which are much more stable. Show us that you're more broken up. 3 and your PGA sign. Perfect. And there we have Act 1, fixation of carbon dioxide. Ding. Okay. In Act 2 of the Calvin-Benson cycle, we will see that the 2 PGA molecules are energized and then reduced by the 2 products from the light-dependent reactions, ATP and NADPH. Okay, so ATP, you are going to come on in. Show us your ATP side. Good. Now you're going to flip your sign over, and you're going to now give that energy to each of the 2 PGA molecules. Thank you, ATP. Now we will see NADPH reduce the 2 PGA molecules by giving them each an electron. And then you should flip your side over too. Perfect. Thank you, NADPH. These 2 3-carbon compounds are now called PGAL. And there we have completed Act 2, reduction. In Act 3, 5 of the carbons will break apart and reform RUBP. But we won't do that yet. Okay. So let's have Izzy as the lone carbon. You're going to be going to glucose. So show us the going to glucose sign. And then the other 5, you guys break apart and then reform up to RUBP. Okay. Now you see that we have the regeneration of RUBP. Are we confused? So there we go. Put away your PGAL sign because you're not PGAL anymore. Now you are RUBP. Perfect. So RUBP is now available for another turn of the cycle. The lone leftover carbon will leave the Calvin-Benson cycle to become part of glucose, the ultimate product of photosynthesis. That's it.